idea of the InShaPe project was to pave the way to a more sustainable additive manufacturing technology, and therefore we have developed additive manufacturing with beam shaping and multispectral imaging.
I'm proud of what we have achieved in this project. We've really shown that with using beam shaping, we can improve the productivity, we can make the AM technology more sustainable, and really open up the game for where additive manufacturing can be employed in the manufacturing world.
We fit to this project really very well because we can contribute by really understanding how beam shape change the microstructure and how this influences the mechanical properties. By changing the beam shape, you somehow change also the microstructure.
The EU-funded project InShaPe was a great opportunity to further investigate and develop the laser beam shaping technology in the field of additive manufacturing. And working together with the customers was a great opportunity learning from the additive manufacturing industry.
Together with our team, out of 11 partners from Europe and Israel, we were able to increase the production speed by a factor of 6. We reduced the cost by 50%, and we even were able to reduce the waste we created.
On the visible near range, we just change some wavelengths, adapt some wavelengths according to our partner choice. And then our colleagues Technion could also realize their thermal analysis on the project. So it's this project that helped us to, in fact, develop new cameras.
Achieving such results, it's really hard without collaboration with other teams. We have insights and kind of like more recommendations from the other collaborators, so we could progress very fast, relatively, and reach very good results at the end of our project.
Working on a cutting-edge technology and solving an industrial problem was priority for me during my PhD, and fortunately, I achieved both within working in the InShaPe project.
The productivity improvements have been achieved without the usual sacrifices of product quality or mechanical performance. We're seeing, in some cases, an improved surface roughness of the components, and we have reduced the defect density, so we have achieved the same, or in some cases, even better mechanical performance with this improved productivity that we just mentioned.
The future of sustainable metal additive manufacturing starts exactly now.